Well, hello everyone, and welcome to today's webinar on exploring the world of natural language processing. I have with me Lakshya. Lakshya is a senior data scientist at Walmart and has previously worked at Adobe and Samsung. Hey, Lakshya, thank you so much for joining us.
Yeah, hi guys, hi guys. Thanks for having me in.
Great. Would you like to give a short introduction of yourself before we get started? I'm sure everyone here would love to know about your experience and how you got into the work of data science today, as well as natural language processing.
Yeah, sure. So I started. So my degree is in mathematics and computer science. So that was a start for me. So I graduated from IT Kanpur in 2016. So at that time in the college, I took courses on mathematics, computer science, statistics, and some machine learning courses as well. So post that I joined Samsung, and there we were given. So I joined as a software engineer. So they were like at that time there were not many data scientist position as such. Either they were a data analyst or a software engineer. So yeah, I joined as a software engineer and I chose that NLP team there. So I started working and kind worked for 2 years, and I worked on their voice assistant, which is Bixby. It's very similar to Siri.
Right.
So, I mean, at that time in 2016, when I started there, that whole deep learning wave came into picture, the whole LSTMs and those earlier language models came into picture. So we kind of started using that in our voice assistant. So they were pretty successful at that time. So yeah, I mean, uh, for 2 years I worked there and then I joined Adobe post that. There I worked in their advertising cloud team. So I'll give you a example for it. Let's say whenever you search for anything or on Google search, right? You get all those advertisements, which is something like, let's say you search for buy red shoes and you get some advertisement from Amazon, Flipkart, right? So those players, those companies are actually paying Google are placing a bid on the search engine to show their ad on the top, right? So our job was to help those companies set those bids, right? So let's say they have a portfolio of some 100 ads and they have a budget of, let's say, what, $1,000. They want to split that budget amongst those advertisements. So then that becomes a predictive modeling problem and is a mathematical optimizer over it, right? So I worked there for a couple of years and then I joined Walmart around 1.5 years back in 21. In Walmart earlier, I was in their membership team. So again, it was some predictive modeling stuff where we were predicting when should we show some sort of prompts to the people who are coming to the Walmart store. Post that I moved to NLP team here. So right now we are working on their conversational AI platform, and I'm also working on conversational shopping, which is like shopping on the e-commerce website, but in a conversational sense that you are saying, okay, buy a shirt, then you are defining it to this. So yeah, that's where I am today. Yeah.
That's amazing to hear. You've worked on a wide variety of different products and platforms in the same space and working on some very interesting things today. Would love to get a sense of how you got into this domain, or why did you pick this specifically as your career?
NLP. So it's a long story. After my second year, I was in one of my internships in a university in Germany. So there, my professor at that time, I didn't know much about machine learning as such. So one of my professors there actually told me about all these things. So at that time, there were statistical methods in natural language processing. There were not many deep learning methods. So he told me about all these things which you can identify sentiment from language, right? And things like that. And that kind of gave me that interest, right? Because it's language, vision, computer vision, natural language, audio processing, right? These are some of the ways which are like one of the true, I don't know, one of the very interesting applications of machine learning system, right? Where machine is understanding, let's say vision or language, right? So I think that is something that kind of made me pursue this NLPs. Yeah.
Awesome. Well, I think everyone here is very excited to see what you have in store for us. Would love to hand over to you and let you take it ahead for today. Everyone, handing over to you, Lakshan.
Sure. Let me share my. I hope it's visible, right?
Yes.
Okay, good. Yeah. So natural language processing, right? So I mean, it's basically in very simple terms, it's making a machine understand your language. And by language, the natural languages like English, Chinese, and languages like that, right? It's so a language contains a lot of rules and a lot of structure is present there, right? There are languages which doesn't have any structure. There are languages which has structure. So the thing is, how do you make a machine learn that? Now, in the earlier developments, right? Okay. So there was this very famous chatbot that was developed, I think, in 1960s, which goes by the name Eliza. I'm not sure I'm pronouncing it right, but yeah. So it was psychotherapist chatbot where you could ask it some questions and it has some rule based system which kind of tries to learn the phrases that you are saying, some tries to pick up the keywords in your question, and then there is a rule based answer that is present here which it will output, right? So there's not much machine learning as such here, but it's a rule basis. You can think of it that way. So that is the one of the first very chatbots that people actually use and people actually like, right? So okay. So later, I mean, as I mentioned, right, there were some statistical methods that were used in NLP in the earlier days. And by statistical method, it's something like, let's say, it tries to find out the occurrence of some words together, let's say, right? So, and it tries to memorize that okay, these two words occur together very frequently. So if I'm trying to predict the next word, this might be a word, right? Now the problem with this is there are, I don't know, a lot of combinations that can happen, right? You can't learn every combination, every detail of the language, right? So that's why that was the biggest limitation of these statistical methods, because you can't just learn every sort of structure in a language, right? That's not possible. Okay, so that basically led us to deep learning and neural network based systems, which are currently being used. So before I come to BERT, so it's not like there were no algorithms. So there were the algorithms like LSTM that I was mentioning, RNS have been there for decades, right? But the main problem was not algorithms. The problem was computation power. So there was not that much of computation power earlier, right? So you had these algorithms, but you can't actually use them on big data, on big language data, right? So but post that with the rise in GPUs and then these libraries came. So these libraries provide you the interface over your over your computer, right? So libraries like Theano in the earlier days, then came Cafe, and then you got these TensorFlow, PyTorch, and the modern ones. So after all these things happened, then LSTMs kicked in, and then you had some. Then Google started using them into their machine translation, the translate website that you see, right? The Google Translate that you use. Yeah, so Google actually started using LSTM based model there. And then I think in 2018 or 19, I'm not sure about the year, but the transformers came into picture. Now, transformers is a base architecture, I would say, is an algorithm, but it's a base architecture on over top of it. All these different modern models are being built. You might have heard GPT, right? That's built over on transformer. BERT is built on transformer, right? So transform is like a base model. It's so one of so these all these are some variations of the transformer model. Yeah. So let me go ahead. Okay. So I'll talk a bit more about BERT and GPT. So these are the models which are trained on very big data sets. Like GPT-3 is trained on, I don't know, some half a TB of data set, which is very big. If you consider the data set is just text data set, right? So it's trained on half a TB data set and has some billions of parameters, right? So these models are use the transformer, as I mentioned, to learn from a big corpus, and they learn the structure of a language. They learn how words relate, how what different words mean in different contexts, right? So these models automatically learn if, when you say, I want to buy Apple stock, you are talking about the company, not the fruit. And this is a single model that is learning all those structures. It's not, if it was a statistical method, you have to learn different structures with different models, right? So this is a single model that learns all these things just by using a big corpus. It just learns from the data that is provided to it. Yeah. So let's go to the use cases. There are plenty of use cases, and they are just like it's just the beginning of it. I would say. So customer, every sector can come here. So customer care is something which is, let's say you go to ICICI website, there's a chatbot that pops up, right? And you want to find out your bank account, I don't know what, your IFSC code, let's say, right? So a lot of people are asking for the same thing. If they keep on calling their customer care number of ICICI Bank, it would be a problem, right? So they build up a chatbot which basically identifies if you are asking for IFSC code, right? You can use different variations. You can say, I want my IFSC code. You can say, what is my IFSC code? Something like that. But the ML algorithm will understand, okay, you are asking about IFSC code. It will give you the output, and there is no human in the loop that is involved now because of the chat. So these are some of the, I mean, there are a lot of use cases in customer care. You can identify the sentiments of customers, right? If a person is angry in his email, right? If he's writing an email to the customer center, a customer care center, and he's writing angry email, or you can auto classify things. You can extract information from the emails, from the product reviews, right? Let's say Amazon wants to extract useful phrases from the review that the people are leaving on our product, right? So things like that. Finance, again, I mean, anything can be done, right? There are financial reports that are published by companies every quarter. You can just ML algorithm can find out the useful information from it, highlight that, and give that to you, right? And then not just that, I mean, whenever a new news, so it's used a lot in the stock market, right? Whenever a news comes, right, or a tweet comes, so these companies have, these high frequency trading companies have all these bots, which kind of identifies these patterns. As soon as some new tweet comes or something comes, they kind of identify the sentiment of it and then trade stock according to that. Healthcare is again something which is like very, very big market in the US, especially in the US, right now, because with all these models, recently Microsoft released this. I mean, similar to ChatGPT, released a BioGPT, which is again trained on the healthcare data, right? So there are a lot of use cases in healthcare as well. I mean, in the US, there are some. I'm not the expert in the domain, but there are some. I mean, every person when he is diagnosed, there are certain tags that are associated to his diagnosis. So you can automate that through a machine learning algorithm, through a natural language understanding algorithm. Right? So it saves hours, tons, like thousands of hours for people manually doing that process. So yeah, I mean, there is no end to application. These are just three domains, but I think every domain actually using NLP in one way or another. Okay. Okay. So let's see ChatGPT. So ChatGPT, I'm 100% sure everyone of you have heard in recently it has been the limelight. So this is like I don't know. These are the things that even we are like very new to the algorithm that they are doing. We are also like looking into it, how they are performing it, right? How they are doing all the training and stuff. We try to just have a overview of it. We'll give you some idea how they might be doing it, right? So before going to that, I mean, ChatGPT, everyone is aware, right? It's a interface that they provided. It's a model in which you can ask questions and it gives you an answer. Then you can ask follow-up questions as well. Right? So it has that context management thing going on. So for this, they needed a lot of data to train their models, right? So by data, you can think of like, let's say there are three sequences of, if I have asked something, then then the ChatGPT has replied something. Then I ask again something, then ChatGPT replies. So these are like the blocks of conversation, right? So it is trained on such blocks. Given previous history of chat, what is the next output that ChatGPT should give, right? So it's trained on that form of a data set. So the first model they talk about is a supervised model, which is again, like I mentioned, right? Given some previous history, what is the next sentence? What is the next output that the ChatGPT should generate? They are training a supervised model on it, right? So this is a supervised model, what they are doing. Now, the thing is, problem with this is when you are doing the inference, right? If this model kind of generates one small error, since it's a conversational thing, right? It goes on, it continues on. It's not like that a final answer that ChatGPT has given is the final thing. No, the user might ask follow-up question. So that error might get exponentially escalated, right? And it might just start putting some garbage after a point of time, right? So to handle that thing, what they did was they introduced reinforcement learning here. What they did was they again took the output of this model and they didn't just take one output, they took multiple outputs. Which, so let's say you given an input to this model, they basically take up, let's say, four most probable outputs that that ChatGPT should give, right? And then they use they use manual labeling to assign ranks to those outputs, right? So there are actual folks who are sitting there during the time of training, people who worked on like reassigning them into ranks, and then this became a new data set, and they call it as a reward model, right? So given an input and given out some multiple outputs from this model, what is the rank of a particular output is a reward model now. Okay. So this is the second one. Now they kind of use this model to improve the first model, to fine tune the first model. So every time something new is predicted, they kind of calculate the reward for it. That I mean, how good that is, how good the output that is, and then they use it as a feedback mechanism to improve their results. This is like the overall understanding of it. So if you want to like summarize it, it's a supervised learning, and then there's a reinforcement learning over it. Right. So I know for people who are new to this field, all this reinforcement learning and supervised learning might not be very intuitive, but it's I mean, if I have to like uh put it in simpler words, a supervised learning is where where you have labels with you, right? Where you have some data set and you have some labels. You're trying to learn the function between the two, between your data and your labels. And a reinforcement learning is something like given a state of a system, what action should it take next? So in games, it's very common, right? Given the state of the current chessboard, what is the next action I should take? This kind of thing is this kind of strategy is what we learn in reinforcement learning. It kind of simulates any game that you can think of, any game, right? So yeah, I mean, ChatGPT is pretty much, this is what my understanding at least is for the ChatGPT. But again, they have, I mean, this was just one of the models that they wanted to show the world to get some traction. But again, Microsoft bought it, and now they are like modifying and putting more layers on it to cater to different use cases, right? Different business use cases. So that is the most important thing. Once you have these kind of models in NLP, that's the whole thing. You get all these models from companies like OpenAI, which are trained on a big data set. And then smaller companies or, come up with products which use these models as an underlying layer and then build products for specific domain. That's the whole practice now, right? So people are generally not trying. I mean, people in companies are generally smaller companies, rather I would say, are not trying to reinvent the wheel. They are mostly using the state of the art algorithm to build products for their users. That's it. Right? That's the whole NLP game going on right now. Yeah, future is more the first thing, like ChatGPT is a generic model, right? It's trained on a big data set, which is not very domain specific. So, like I mentioned, right? Microsoft released a medical ChatGPT for trained on medical data, right? So, similarly, other domain specific. So, LLM is a large language model. ChatGPT is one large language model. BERT is one large language. So, more domain specific large language model is one thing that will come, are coming, and will definitely come, because those are the ones which are actually more useful. So the models like ChatGPT are useful mostly on the content creation space. If you are using it barely in the bare form in which it is present right now, but if you want to use it to a domain, to solve a particular domain task, then you might want to use that particular domain's long language model, right? Smaller models, of course. So right now the models are big. They require servers. Right? So let's say if you want to put ChatGPT on a phone, right? Model. You can't do that right now because it's a big model. So smaller models is something that will definitely be people are working on. People have been working on for some time on this, on building smaller model. Improved language understanding is I mean, it's a generic thing that will go on always, right? I mean, these are basically improving the algorithms, underlying algorithms. More efficient and accurate translation, yes. So translation is one thing which is, I mean, solved, but it's not solved 100% right now. So translation, I mean, more efficient and accurate translation is something that people are still working on, and especially in languages which are difficult to translate. Right? Personalized communications. Personalized communication is again, I mean, it's something like there is a communication, but can you take more input, take more modes of input into it, right? Like some other form of data that you can provide to a language model. So based on your current state or based on your current something like some sort of data points, the output of the language model can change, right? So something like that. So that is something. Greater integration with other technologies is integration is again something which is being done. Like I said, it's a layer above your all these models. So that's pretty much going on. Improved accessibility is something, yes. I mean, it should be accessible to everyone. That is one thing. Right now, big players are training it and they are like, I mean, it's accessible, but it's not very open source. In an open source fashion, they are charging for it. Right? So that's one thing. And um, another thing is, I mean, I don't know if it's part of this, but it can be used like it's like if a computer can understand language, right, it can help a lot in terms of people who can't see, right? People who can't hear, things like there, it can be a help. It can be really helpful. Like there are some computer vision products right now which helps people, which help blind see. I mean, not see, but kind of feel around whatever is happening around them, right? Get the idea of that. So yeah, I mean, yeah, I had this much. People, I can take up questions maybe.
Awesome. Thank you so much, Lakshya. We have quite a few questions in the chat.
Mhm.
Why don't we get started in answering some of those? Uh, Someone is asking, Ankit is asking if you can help with maybe another real world example of NLP other than ChatGPT, something that you find unique and very useful.
Okay. Lot of examples actually. Maybe I'll just give you this thing. It's actually pretty. So, if you are interested in NLP, right, just go to this website, Hugging Face. Uh, this website kind of hosts a lot of models. People just put their models here, which can be used to solve a lot of different tasks. So I don't know. Let's just so there are a lot of things that you can do with NLP. Right? You can paraphrase your things. You can output your sentiments, and let's just see. I quickly demo it. So, okay, I should have done that. Let's see. This is a pretty cool thing. Okay, so so this is a good term, zero shot, that is very famous in the deep learning community. So zero shot is something which means you don't need any training for it. Still your model will be able to predict whatever you are trying to predict. So let's say if you have a text and you want to if you want to get classify it into several terms without training it, right? This kind of model can help you do that. You give your sentence, you give your paragraph, and then put whatever labels you want, right? To classify it into, and it will give you some sort of. So, like here, you can say, I have a problem with my iPhone that needs to be resolved ASAP. Automatically give some sort of labels here, and you want your model to give probability to these labels. What matches the best is occurrence, right? And it gives you, okay, urgent is the highest thing, phone is the highest probability that the user is talking about, right? So this is pretty cool. So remember, we didn't train it on this data set, right? It's not like we have trained it earlier. This is a simple model which in which you give any set of class names and it will classify that. Zero shot learning, right? This is pretty cool. Sentiment analysis is again something similar. Any tweet you read, you can classify it as positive sentiment, negative sentiment, maybe a harmful tweet, right? Uh, generative models like ChatGPT, but I won't go into that because we already covered ChatGPT. So that's fine.
Awesome. Sure. I'll move on to another question that we have here. Can you deep dive a little bit about the transformer model that you had mentioned?
Okay. So transformer model works on app. So I'm not sure how many people are aware of the basic, but I try to like uh, explain it simpler terms. Okay. So transformer is a model that tries to encode your input. So see, your input is a natural language sentence. Let's now your computer doesn't understand language at all. It understands binary, right? So you need to convert it into numbers in some form. So now the this is called encoding in the terms in the world of NLP. Encoding anything. You can encode a word. So when I say you encode a word, it means converting a word into a vector of numbers. You can encode a sentence into a vector of some numbers. Now all these algorithms does or do this kind of thing, right? So a transformer is a model which takes it input as let's just consider this sentence. Okay. It takes it input as this sentence. Then there's a concept of attention, self attention. Um, I don't know. I just said so. The attention is something like whenever you are at, let's say the model is trying to understand iPhone, right? It needs information from other parts of the sentence. Like I mentioned, right? There can be a sentence buy Apple stocks, and there can be a sentence buy Apple, buy a green apple, right? So you as human, you like instantly recognize, okay, the first apple is a stock, the second apple is fruit. Right? But how will your machine understand? So while the machine is trying to understand iPhone, while the transformer is trying to understand iPhone, it looks up into the nearby points and it sees, okay, iPhone is coming in this context. Then it goes to the next word. It sees, okay, that is coming in this context, right? Along with these. And then you do some mathematical multiplications onto these weights. Those are called weights. You basically arrive into some sort of mathematical vector in the end. And that vector represents your whole sentence. Okay. So that
Got it.
is embedding a sentence into a vector. That is what transformer does, essentially.
Got it. Awesome. We have another question from Dipendra. Can you explain how we can train a pre-trained model?
Train a pre-trained model. So we
Yeah.
can fine tune a pre-trained model. So how that works, that's actually that's a very interesting and very frequently done thing, which is called transfer learning in deep learning. So transfer learning is something like you have some pre-trained model, which are being trained on big data sets, right? And so what do we mean by a model? We need to first understand that in deep learning, a model is basically a collection of weights that you have learned. And by weights, I mean numericals, some vectors, right? That you have learned. So a pre-trained model is this set of vectors, set of weights that you have already learned. Now, what you do is you bring in some more labeled data that you have, and then during the final layer of your model, right, the prediction layer of your model, you just fine tune it further with the additional data that you have, and then this new model is a fine tuned version of your the base model. Now, the benefit of this is the base model that you have is trained on a big data set, which is trained by or some companies like OpenAI, right? One, yes, I really found you. Computational power. So, so basically, that provides you the, what do you call it? The kickstart, the kick for your, um, or rather the base for your further fine tuning of with the new data set that you. So you don't require a lot of new data set to actually get a decent model because you are using some pre-trained model on a generic data set. That is. Yeah.
Got it. We have another question from Sapna. Can BERT be used for multi-class classification in LLP?
It can. I mean, why not? So BERT is again BERT. Let's say I mean, it's similar. Like when you pass an input to BERT, a pre-trained BERT, it outputs you some vectors. One of the vectors out of all those vectors represents the embedding of the whole sentence. I mean, it represents the meaning of the whole sentence, and then you can use that vector, and then use another small any algorithm, any ML network to predict class, to train the class with the classes that you want to train with. Right? So it's essentially what word gives you is is collection of vectors, and one of the vectors is your um, vector representing the whole sentence, right?
Got it.
So you can do anything that you want with it after.
Got it. Pavan has an interesting question. How can we build our own speech recognition, text to speech and speech to text?
Text to speech and speech to text. Okay. Sure. I mean, I haven't worked on that, but I can maybe, I don't know. So let me see. I mean, in the industry, it's called ASR, audio speech recognition, but I think which you are talking about. So language is, sorry, the audio signals is represented in terms of signals. Again, I'm not expert in this field, I haven't worked there, but they are represented in terms of signals, which essentially becomes a time series signal, right? Which is a sequence. And then you use some methods, uh, uh, some deep learning sequence learning methods to classify them or, convert them into text, right? So, I mean, my understanding it should work somewhat similar to your machine translation algorithm, where there's a input, there's a sentence, and output there's a sentence. But here input you have audio file, which is again can be converted into a time series of, or rather a sequential signal string. Again, I'm not sure. I'm not very expert in this field, so
Got it. Lakshya, do you mind stopping the screen share? We can see you
oh,
better that way.
okay.
Got it. So, coming to, we see a lot of questions here, say, on students looking to transition into careers of data science and eventually maybe work on these sort of projects. What advice would you have for folks who are looking to transition into data science from different careers? And any tips and tricks that you think that they should be doing today in order to have a successful career?
See, first of all, I can talk about what exactly you can do to improve your chances in getting into this career, I would say. And then I will continue with what are the things that you can keep yourself updated with or keep yourself with to progress in the career. Right? So I think some of the very important things are knowing the fundamentals. I would say the first thing. So by fundamentals, I mean know your mathematics. By mathematics, I mean some level of linear algebra, basic level of that, some statistics, some, and then about the algorithms, of course, right? So all those kind of things is something that you should be good with. Other thing I think is language. Of course, you will be coding, right? So you should know languages like Python, maybe SQL if you are working on tabular data, things like that, right? So that is one thing. Apart from that, I would say one, not just the theoretical knowledge, you should be like working on some sort of applied knowledge. By applied, I mean try to get your hands on some of the projects. Now there are, I mean, two kinds of projects, right, that you can practice on. One is projects that are present on Kaggle or platform like those, which are there's given a data set and you just need to build a model and predict and report the accuracies, right? So that is one kind of project that you can do. The other kind of project that industry generally looks for is the end-to-end project, right? Or what do we call it as a full stack data scientist, right? So that includes your um, processing your data. So that is one thing. Building models, that is the next part. And I think the third very important part is deploying it into production, right? Deploying it to production and then maintaining your model. So all those knowledge you should at least have. To I mean, those are some of the things that a company looks at when they are trying to assess you, right? During maybe an interview, or things like that, right? Again, you can maybe, I think one of the things that really people do in the States, in USA, but not in India so much, is building their portfolio. And by portfolio, maybe a GitHub profile for you, maybe a Medium profile for you, right? So building those profiles, put up your projects there. It's okay if they are not perfect. That's completely fine. It just shows that you are interested and you kind of work on those things. You have worked on those things. Medium is really a good platform where you can put up whatever you have learned. You can just write it there and maybe publish it for the other folks. So it shows your interest in the field. Yeah. So these are kind of the portfolio things that you can definitely do. Apart from that, networking is very important. Just talk to people on LinkedIn. who are maybe right now who are working in the similar domain or similar kind of role. Just ask them what they do. Maybe how can you get, if you are interested in their company, how can you get into that, right? How can you get into those roles? And I would say try to, in this, at least if you are very in a very early stage of career, right? Don't stick to a particular domain. Try to learn about different domains. Try to see how ML is being used there. So don't go the other way. Don't start by looking into, okay, where can I put this ML algorithm? Rather pick up a domain, find a particular problem, and then see what kind of algorithm, how can you solve it by ML. So that is a very important thing. Don't go in the opposite direction. Yeah, I mean, research about the domains, research about how machine learning is being used in all those domains, right? And then maybe if you're interested, you could find companies which are doing similar work, and then you can show your interest there to them. And I think they would really like if you have done your homework and you have some interest in the particular field they work in. So yeah, I mean, to summarize, fundamentals, mathematics, statistics, and of course, machine learning, the basic algorithms, languages, networking, portfolio.
So, for everybody looking to build their portfolio when it comes to data science, I would give you another tip. And you can use Jovian as a platform for your data science profile. You're able to upload your projects, work on projects, as well as showcase all of your work within the Jovian platform itself. Another question that we have, do you have any interview tips, or say when it comes to resumes, how would you today, if you had to apply for these roles, go about it?
Okay, yeah. So I do that all the time because I'm in Walmart, I'm taking interviews. So yeah, so the kind of things we look into generally. So there are rounds, right? First of all, it depends on the company. There can be a coding round, there can't be a coding round, right? So that is something that you need to look into. That is not directly related to data science, but I would say there are companies who take coding interviews. So that is one thing. Second thing, specific to data science, what we go into is models. And see, I will give you a tip. So within the first 5 minutes, we actually understand the person has done things or he has just written that on resume. That's very evident. Like within the first 5 or 10 minutes, we can say that, right? So please, whatever you're putting in the resume, please do that. Then only people understand who are taking the interview.
Yes.
Second thing is whenever you are trying to understand any algorithm, let's say I take example logistic regression, right? Don't just try to get a very superficial understanding of it. Don't just try learning every algorithm. Don't become expert of all, master of none. Don't do that. Just pick up couple of algorithms or the algorithm that you have used in the past and build a very deep knowledge about those algorithms. Right? Don't just try to have a very shallow understanding about all the algorithms because people just will go into one of the algorithms. Let's say you say logistic regression, you should know the mathematics of it. What's the pros of it? What's the cons of this? When should we use it? What will it do to the outlier detection and things like that? To when the outliers are present and things like that. So pick up algorithms which you have a very deep understanding.
Got it. Awesome. We have another interesting question here. If you're open to answering what the use cases of NLP are at Walmart.
Yeah, well, like something that I am working on is conversational search. So as
Right.
I explained, right, it's something like you are searching but in a conversational form. You are saying, okay, show me shirts. Then you go at, okay, show me red shirts. Then you say, don't show me, I don't know, some variety, this color, but this shirt, something like that. Right? So
Correct.
it's a conversational form. That is one of the use cases. Another use case is your product reviews, where people are like leaving reviews on your products on the whole Walmart's products, right? I mean, manually going through those reviews is something that might be tedious, right? So you kind of build up a system where, so they are actually systems which gives you the important terms from that products or the reviews. I think that you can also see on Amazon, but I guess no, the website where you see the highlights of the reviews. NLP is used, I think, a lot of other places. In the feedback, yes. So customers give a lot of feedback, right? Those feedbacks, since Walmart is I mean, it's not a very new company, so the methods are still, the detailed feedbacks that
Yeah.
are taken, and maybe sometimes they are taken on a piece of paper, right? So yeah, I mean, those are language based. I mean, people actually write stuff there, so you need to kind of bring insights from those feedbacks. So there is NLP is really used a lot. I mean, these are some of the cases I'm aware of. Again, the search is there, the normal search, of course, NLP use there. Um, yeah, I mean, there must be other cases there.
Got it. Awesome. Thank you guys so much for dropping in all of your questions. I think we'll just maybe take one last one and then close. Okay, I see one here. If you had to explain NLP to someone who is 8 years old, how would you do it?
Okay. NLP is again, I mean, as I said, right? It's kind of making a machine understand our language. That's it. What we are trying to say, making a machine understand that. That's NLP. And that's exactly what NLP is.
Perfect. Awesome. Thank you so much. And any parting comments that you would have for folks looking to build a career in data science before we close?
No, yeah, I mean, it's a really interesting field. It's a really growing field, I would say. I mean, it's just the beginning. Uh, so please, there's a lot of things that are going on around. Just try to read news. Just try to read news about machine learning. Just Google search, right? So try to follow people on Twitter if you are, if who works on like who constantly posts on these similar topics. So yeah, I mean, and just network. I mean, networking is very, very important and creating a portfolio, right? Like Ananya said. I mean, you can create portfolio at different places, but yeah, I mean, that's very important. But networking and portfolio is like one of the very, very important things that you need to do and you should do.
Got it. Awesome. Thank you so much, Lakshya, for taking the time out this evening and joining us. Well,
Yeah.
thank you and good night, everyone.